Once upon a time, I created a short related to carbon dating. I received so many comments for detailed video, so here we go. Radiocarbon dating, also known as carbon-14 dating, is a scientific method that can accurately determine the age of organic materials as old as approximately 60,000 years. The method was developed in the late 1940s at the University of Chicago by Willard Libby and is based on the decay of the carbon-14 isotope. Radiocarbon dating has been used for historical studies in atmospheric science, and triggered archaeology's radiocarbon revolution. The technique is based on the fact that living organisms absorb carbon-14 into their tissue. When they die, the carbon-14 starts to change into other atoms over time. Scientists can estimate how long the organism has been dead by counting the remaining carbon-14 atoms. The process starts with cosmic rays that form the radioactive isotope carbon-14 when they reach Earth's upper atmosphere. Living organisms absorb this carbon-14 into their tissue. Once they die, the absorption stops, and the carbon-14 begins very slowly to change into other atoms at a predictable rate. By measuring how much carbon-14 remains, scientists can estimate how long a particular organic object has been dead. The technique was developed in the late 1940s at the University of Chicago by chemistry professor Willard Libby, who would later receive the Nobel Prize for the work. News of the technique spread rapidly, and by 1960, more than 30 radiocarbon labs had been established worldwide. Today, scientists also use a different way to measure carbon-14 called accelerator mass spectrometry, which can get more precise results from a far smaller amount of sample but is more expensive. Carbon dating can be used on any object that used to be alive. That includes pieces of animals, people, and plants, but also paper that was made from reeds, leather made from animal hides, logs that were used to build houses, and so forth. However, conventional radiocarbon dating requires samples of 10 to 100 grams of an object, depending on the material in question. Newer forms of dating can use much smaller amounts, down to 20 to 50 milligrams. In both cases, the material is destroyed during the test. Radiocarbon samples are also easily contaminated, so to provide accurate dates, they must be clean and well preserved. Dirt and other matter must be washed off with water, but chemical treatments and other cleaning procedures are also often needed. This is because there are so few atoms to count. Even a little extra carbon from contamination will throw off the results significantly. The technique has had a major impact on our understanding of fields from archaeology to history to geology. It has been used to check the veracity of claims about artifacts. For example, in 1989, radiocarbon dating tests established the age of the Shroud of Turin to be between AD 1260 and AD 1390. The shroud allegedly had been used to wrap the body of Jesus after his crucifixion in AD 33. Today, archaeologists continue to use carbon-14 dating in their research. For example, the Chicago Tübingen expedition to Zinkerli in Turkey used carbon-14 to date a destruction layer of the Middle Bronze Age, a period whose dates have swirled in controversy for a century. Radiocarbon dating is also helpful in reconstructing how the climate on Earth has changed over time. For example, before carbon-14 dating, scientists believed that North America's last ice age ended 25,000 years ago. But Libby's analysis of wood samples from trees once buried under glacial ice showed the correct date to be no later than about 11,000 years ago. Carbon dating has also been used to understand how carbon moves between the atmosphere, oceans, and land, as well as the Earth's magnetic field. All key to making Earth habitable for life. Carbon dating has also helped us understand the sun and its activity. Fluctuation in the solar wind causes changes in the amount of carbon-14 made in the Earth's atmosphere, so researchers can recreate a history of the sun's cycles. Radiocarbon dating also played a significant role in the discovery of human-caused climate change. Carbon dioxide in the atmosphere has increased sharply, but how do we know it's from burning fossil fuels and not from other natural sources? We can measure how much of the carbon in carbon dioxide is carbon-14 versus other isotopes of carbon. I hope you liked the video. Please subscribe my channel if you haven't already. Thanks for watching.